Okay, so I think we can start. So the next speaker for today is Professor Enzo Bonacci. He is from University of Athens in Greece, and the title of his talk is shape optimization in about crystallization of CAM.
Perfect.
Okay, so you are
So
right.
thank you for this wonderful conference. It is always a pleasure to be here. And this year, I'm going to talk about the shape optimization in the batch crystallization of CAM. So the state of art in 1997 about citric acid. It is an important organic substance, but until 1997, the scientific literature reported little information about the crystallization by cooling in stirred tank reactors, STRs. That is the process by which the commercial product is obtained. The studies then available were focused mostly on the kinetics of nucleation and on the crystal growth, rather than on the industrial aspects of the crystallizations in STRs. Well, La Sapienza is the largest university in Europe, and there is the Department of Chemical Engineering, which decided to fill that scientific technological gap through a detailed investigation on the crystallization in this continuous batch of the citric acid monohydrate at San Pietro in Vincoli's laboratories, called DICMA. The author participated in that cutting-edge experience under the supervision of Professor Barbara Mazzarotta in the years 1997-1998. We were seeking for an optimal CSD of CAM. What is an optimal crystal size distribution? It is large crystal and homogeneous. We were looking for which conditions could bring to such optimal crystal size distribution. And we wanted also a confirm via computational fluid dynamics. So we wrote also a QBasic program predicting the outcomes of any test. The resulting thesis and the related research papers were acknowledged as pioneering achievements more than a decade later. Finding the optimal shape of STRs. Here we expound only the influence of the STR's geometry. The best CSD, a homogeneous distribution of large crystals, always comes from round bottom tanks. Hemispherical tanks perform slightly better than conical and much better than flat, discarded in industrial practices. It was based on experimental tests and computer simulations, and the results seemed valid beyond the limits of our survey on CAM. We carried out a meticulous testing, and we found that the conditions, the optimal conditions, can be summarized as follows. 3-blade marine propeller as impeller. Agitation speed around 2% above the minimum value for solid suspension. Seed crystals large around 10% of the desired final size. Seeding temperature about half degree over that of spontaneous nucleation. Tank crystallizer with a round hemispherical bottom. In this talk, we illustrate the last achievement, that is, the role played by the STRs in crystallizing the CAM thanks to their differently shaped bottoms. A strict protocol. This is the protocol we followed to conduct each test. So solubilization by heating, crystallization by cooling, separation by filtration, Brenner on exposure to air, classification of the crystalline product, analysis through the optical microscope, and pictures of some crystals specimens. Comparing our three STR shapes. Here we can see in detail the volume, total height, height of the body, etc., etc. You can see flat, the orange column, round, the green column, and conical, the blue column. Comparison among tests. We can see three different colored curves, and you can see that the best performance is the one, the curve in red, that it is full of circles, that mean hemispherical button. Medium performance is the green line, that means the conical hemisphere, and the worst performance was the flat button. The best two STRs are also compared on the right side, and you can see that the conical one is slightly better than, excuse me, that rounded one is slightly better than the conical one. So they are exactly the devices we used, the things we are talking about. Round button on the left and conical button on the right, the best two. We interpreted our tests about optimal shapes. We could discard other factors by testing them. For example, the heat exchange could be a factor misconceiving something that could affect our conclusion. But we tested apart the heat exchange and we could discard it. Also the agitation. So the shape was found optimal exactly in the order I said before. So hemispherical or rounded, then conical, then flat shape. Computational fluid dynamics. This is the real problem with citric acid. Citric acid has prohibitive fluid dynamics. So this is the main reason why until 1995, it was almost impossible to compute the citric acid monohydrate fluid dynamics, because in 1995, it was established Visimix, the software Visimix. And La Sapienza Rome was one of the first universities to buy it and to use it on each computer of the chemical engineering department. With Visimix, it is an incredible software. You can find online also the review of the main mathematical models using it. Something that was impossible until 1995. So the compute the fluid dynamics of the citric acid monohydrate became easy. We were very quick to learn how to use it, and after using it, we found exactly what our tests said in the same period. So a shape to be avoided, and you can see the flat bottom tank with an ineffective flux. An acceptable flux, not optimal, but acceptable, a possible shape conical. The best shape rounded. And also the Visimix confirmed it was the best shape. You can see those shapes from the top. But we tried also a new program in QBasic. The available programs were focused on potassium sulfate. That was very easy. but citric acid monohydrate was very difficult for two reasons. A strong tendency to agglomeration and secondary nucleation by collision. It took months to write down the subroutines in order to have a good simulation, but we did it. So you can see the results, you can see the comparison, it is quite accurate. This program didn't perform well only with heavy seed, but we don't use it in industrial practice, so it was useless. You can see again two best tanks, and we can reach the conclusions. In the year 1997-1998, at La Sapienza lab, we analyzed the batch cooling crystallization of the citric acid monohydrate, CAM, from aqueous solutions. The choice of a stir tank reactor, STR, with an hemispherical bottom optimized the process, allowing the best suspension for CAM particles. Looking for a homogeneous distribution of large crystals, we found that the conical bottom STR was in second place for efficiency, whereas the flat bottom shape performed rather poorly, providing the lowest crystalline quality. The experimental work was supplemented by a QBasic program to predict the CST and by the Visimix software to simulate the fluid dynamics inside each crystallizer. The acknowledgements are a very long list. The Italian Physical Society, the International Year of Chemistry, the Magna Grecia Prize, the Sapio Prize, Arachne Editrice, a publisher who published the thesis with a sort of honor, Hector Majorana Grand Gala, at other conference, and the last but not least, the AGMA 7th Conference in Odessa. Thank you very much for your attention. These are the references. And those are the image credits. And that's it.
Okay, so thank you very much for the really fascinating talk.